In this lesson, I'll introduce you to the self-consistency prompting technique. This technique improves the performance of chain of thought prompts for mathematical and reasoning questions. I'll go over the results expected from the application of this technique, and finally, I'll show you this technique in action by way of a demo. The self-consistency prompting approach was suggested in a paper available on the arXiv website. The title of the paper is Self-Consistency Improves Chain of Thought Reasoning in Language Models. This technique has shown good results with the problems involving mathematics, logic, and reasoning. It has been tested on various data sets that are heavy on math. So here, as you can see, it improved the performance of chain of thought by almost 18% on grade school math questions. And for mathematical word problems, it showed improvement of up to 12%. To use this technique, you do not need to read the paper. Let's go ahead and dive a little deeper into it. In the self-consistency prompting approach, model is guided to try out n different ways of thinking. This leads to an improvement in results achieved with the chain of thought approach alone. The idea is that by considering multiple perspectives or approaches to a problem, the model may generate more nuanced and robust responses. To use self-consistency approach, start the prompt by instructing the model to simulate n experts. In this example, I'm setting n equal to 3. Each expert will arrive at the answer using the few shots or examples provided in the prompt. The examples are chain of thought prompts. That is, they're not just the answers, but includes steps leading to the answer. Each expert then gives an answer independently. A majority vote is then carried out to determine the final answer. Now, keep in mind the number of experts specified in the prompt will have a direct correlation with the performance, as the model will have to do more work to achieve the desired results. What you see here is a typical chain of thought prompt that leads to an answer. Model generates the response by generating tokens that have highest probability. This mechanism is referred to as greedy decode. This greedy decoding prevents the model to think diversely, and self-consistency leads to introduction of diversity of thoughts. With self-consistency, the prompt is adjusted to guide the model to generate multiple chains of thoughts to solve the problem. This simulation is initiated by the idea of experts. Model generates multiple answers using different plans of actions. The majority answer is picked up as the final answer. Let me show you examples of how this technique is used with math problems. The example that I'm sharing with you here is available in the course guide under the section Prompt Engineering Self-Consistency. I've tested out the examples with AI21 Jurassic Mid-2 model with temperature setting of 0.7 and top P setting of 0.4. Let's go ahead and try it out. I'm going to copy this. Temperature is 0.7, top P is 0.4. Let's go ahead and paste the prompt. In this prompt, as you can see, I'm just providing a couple of shots, question 1, question 2, and then there is a question. The answer to this specific question is 3. Let's run this. And as you can see, the answer here is $0 in change. It should have been $3 in change. Now what I'm going to do is add the self-consistency prompt magic here, which I'm going to get from the course guide. So here in this, I'm saying imagine 3 completely independent experts who reason differently, and I'm asking the model to provide the final answer by way of a majority vote. So copy this and I'm going to paste it on top of the question here. The answer is 4, which is incorrect. Let's change this to 5 and see what happens. So now we are asking the model to simulate 5 experts. And this time it gave us the right answer, which is 3. And here are the answers from all the experts. Every model behaves differently. So if you're using a different model, you may have to play with the temperature, top P and top K settings for the model. I would suggest that you try out these examples on your own. If you don't see the desired results, you can play with the temperature and the top P parameters You can switch to a different model. You can change the number of experts, and you can adjust the language in the self-consistency instructions. And if you want to be more adventurous, try out a different model. And don't forget to share your results in the Q&A chat. In this lesson, you learned about the self-consistency prompting technique that guides the model to solve problems in multiple ways. This technique has shown marked improvements for mathematics and reasoning questions with chain of thought. Happy learning, and I'll see you in the next lesson.